Now we are going to discuss about Rutherford atomic model. Here, after proposing of J. Thomson atomic model, it leads to propose another atomic model by Rutherford. Before he proposing the atomic model, he did an experiment by using alpha rays. That experiment is known as alpha ray scattering experiment. Alpha ray scattering. By doing this experiment, we find some important points and give the model for atom. So, in this experiment, we use the alpha rays. What are the alpha rays? Alpha rays are having positive charge. These are nothing but radioactivity rays. These rays are coming from radioactive element like radium, etc. And also we can say positively charged helium particles are nothing but alpha rays. The positively charged helium ions are nothing but alpha rays. So if helium is 2He4, if we remove 2 electrons from it, it can turn into plus 2He4. These are nothing but alpha rays. So the positively charged helium atoms, the positively charged helium ions are nothing but alpha rays. So we can say that alpha rays are having positive charge. By using these alpha rays, he did an experiment to find some important points about atomic model. So his experiment is like this. First he took a thin gold foil plate. So this is thin gold foil plate. He placed this thin gold foil plate in the center of zinc sulfides. He placed this thin metal foil. He placed this thin gold metal foil in the center of the zinc sulfide plate. This is zinc sulfide plate. This is thin gold foil. Okay. He used the alpha ray source. He allowed these alpha rays through thin parallel positively charged plates. He allowed these alpha rays through these positively charged plates. Now this alpha rays are going through into the gold foil. So these are striking gold foil like this. Here in this experiment, he observed that so many rays were going slightly without any deflection. So many alpha rays were going slightly through this gold foil without any deviation. And also he observed some of the rays were having deviation very slightly. And he observed that very few rays are turned back to its original direction. He observed that very small number of alpha rays were turned back to its original direction like this. If the alpha rays are going in this direction, very few lines are turned back to its original direction. So in this experiment, he observed that most of the rays are going straightly through the metal foil. Some of the rays were deflected slightly, and very few rays are turn back its original direction. So, by observing these conditions, he concludes some points. So, what are they? In the atom, the Rutherford concludes that in the atom, most of the place is empty. In the rays, most of the rays were going slightly without any deviation. That means most of the place in the atom is empty. Most of the place of the atom is halogenous. Why? Because most of the rays were going slightly without any deviation. Halogenous of the atom. Most of the atom is having halogenous. And he observed only very few rays are deflected and very few rays are turned back. That means why these rays are turned back, why these rays are deflected means if these rays are positively charged rays, this should be reflected only if this metal foil, the part of the metal foil, the part of the atom is in positive state. So, if in the atom is there any positive part, only in that case these positive rays will be deflected. So, that means he told that there is some center of the atom is constituted with the positively charged particles. So, very small positive part in the center of the atom. So, he observed that very few lines are deflected and very few lines are turned back to its original direction because there is something positive part in the center of the atom is placed. So, that's why these positive rays are deflected and turned back to its original position, original direction. So we conclude that the center of the atom is concentrated with the positive part. This positive part is named as nucleus. Nucleus. So in this nucleus, there is the positive charged particles. Those are nothing but protons. He told that. So firstly, this nucleus was discovered by Rutherford. Hence, this atomic model is also called as nuclear model of atom. Nuclear model of atom. And they give the information about electrons also. These electrons are revolving around the nucleus. Electrons this information is also given by Rutherford. So in the center of the atom, the positive part is concentrated, that is called nucleus. Hence this atomic model was called as nuclear model of atom. And he said that the electrons revolving around the nucleus as like as planets revolving around the sun. So hence this model is also called as planetary model or solar model. Planetary and solar model. So, why? Because the electrons are revolving around the nucleus as well as planets revolving around the sun. Hence, this model is also called as planetary model and or solar model. So, that is look like this. If it is an atom, most of the part of the atom is empty. That means halogenous. Most of the atom is having halogenous. The center of the atom is having some concentrated with the positive part. This is called nucleus. Nucleus. So the electrons are revolving around the nucleus with large distances. Electrons revolving around the nucleus. This is protons. Protons are concentrated in the nucleus and electrons are revolving around the nucleus. Because of this nucleus, this model is called as nuclear model of an atom. If the electrons revolving around the nucleus like planets revolve around the sun, hence this is called planetary model or solar model. And also Rutherford find the size of the nucleus also. So the size of the nucleus is about 10 to the power of minus 13 centimeters or 10 to the power of minus 15 meters. So this is the radius of the nucleus. Radius of the nucleus. Radius of the nucleus. So which is about 10 to the power of 5 times smaller than the radius of the atom. So the radius of the atom is about 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. This is the radius of the nucleus. Atom radius is 10 to the power of minus 8 centimeters or 10 to the power of minus 10 meters. This information also is given by Rutherford. Though Rutherford has given the new information and most useful information about atomic model, in this model also there are so many drawbacks. In this model, the drawbacks are nothing but, according to classical laws of electrodynamics and dynamics of physics, if any charged particle revolving around another charged particle, it continuously lost its energy and finally the system will be destroyed. So according to classical laws of electrodynamics and dynamics of physics, if any charged particle revolving around another charged particle, the charged particle continuously lost its energy. If electron, the negatively charged particle, revolves around the positively charged particle, the electron should continuously lose its energy, and one day electron will be lost its energy and fell inside the nucleus. But this is not done. This is not happening. Atoms still be stable. Why it is happening? The information, the explanation is not given by the Rutherford. This is one of the drawback. And another drawback is the arrangement of electrons around the nucleus is not given by the Rutherford atomic model. So how the electrons are arranged around the nucleus in the atom is not given by the Rutherford atomic model. This is also one of the drawbacks. So this is the brief information about Rutherford's atomic model.